I'd like to thank Filippos for sending me these chargers that he bought while he was back on a break in Greece. And he went into a Chinese outlet there where they just sell unregulated stuff and got a couple of chargers, and yes, I think they're going to be dodgy. They're certainly very, very small. He also sent me a home-based lamp, which one of his friends had bought and was dead out the packet, and I've already opened up and found the problem. I know, I should have waited for you guys. Not to worry, we can take a look at this. It was just that I couldn't resist opening up, sorry. But let's take a look at the lamp first. I should also mention, a lot of you have been sending me emails offering to send stuff for analysis. I have a huge backlog of emails at the moment. Basically speaking, when I get up in the morning, there's just screens and screens of emails, and I have to filter through them really quickly, and things like tax demands take priority. And then the other ones, I'll check them out, and then I'll most them. If it's just a sort of like, if it's spam, I'll delete it. But if it's the messages you guys have sent, I keep them. But there is now about best part of 1,000 of them. It's getting quite unmanageable. This is something I'll just have to get to grips with at some point. So the LED lamp. So this is a 5-watt LED lamp that was dead out the packet, and I was thinking, well, 5 watts in such a small size, it's probably a switch mode power supply, and it turns out it's not. It's a capacitive dropper. And it was completely dead. Now, the way they've got this arrangement, they've got 6 multi-chip LEDs on an aluminium substrate PCB, he said, rubbing the back and forgetting it's got the silicon compound on it, the heat thermal transfer compound. And the edge of the circuit board is clamped onto this metal frame here in the lamp, which helps take the heat away. It's still a very small lamp for 5 watts. And when I tried to get the circuit board out, I desoldered the back and pulled it out, and it immediately came out. It didn't. It usually comes out in 2 steps, the one when you desolder that, and then the other one that's hooked onto the metal frame. And I was thinking, maybe it wasn't hooked onto the screw thread of the connector. So first thing I did after that was I plugged it into the quick test. He said, plug it into the quick test, and voila, it does light. So that's what was up with that lamp. It was a factory defect. They hadn't connected it into the thread here, and looking at this, it actually looks, the thread looks a bit malformed as well. It's obviously had been a bad day at the factory. So let's check it out. It's supposed to be 5 watts. It says 5.5 watts. So it is effectively a 5-watt lamp. Well, it comes from home base, so it is more likely to be quite realistic in that respect. It does mean that those little LEDs are dissipating the best part of a watt each. That's quite a lot of power for those dinky little LEDs. I'll let you have a wee look at the circuit board here. Typical capacitive dropper, the bridge rectifier, the dropper capacitor that limits the current in each half wave, the smoothing capacitor, which doesn't really quite 100% smooth as you saw from the shimmer, and then these multi-chip LEDs. So that's that resolved. Unfortunately, to actually repair it, you have to open it in a way that I'm never ever going to be able to connect it into the back of this again, because this is crimped. So it's a bit of a, it's not easy in the sense of, I suppose you could rip the back off, you could put a flex in, but that'd be kind of defeat the point. And also it is going to get a very hot lamp. I'm not sure how long that will last. So let's take a look at these little power supplies. So let's get the quick test down out of the way. I have high hopes for these, and I don't mean that in a good way. It's going to be super trashy, I just know that, because of they're so small, and this is smaller than normal. This just feels tiny, and it's got that little plastic wrapper that says, I'm a genuine Apple product, when it's really not. It doesn't, does it say anything in the back? No, it doesn't pretend, at least. It doesn't, you know, it doesn't pretend it is an Apple product, which is quite good. Does this one have text on it? It does have some text at the back. Let's see. Are they optimistically saying 1 amp each? 5 volts at 1 amp. I'm going to be able to show you this. Might just show. Actually, if I turn the lights on it, it'll be better. Yeah. And this is also. Oh, yes, 1 amp plus and minus 50 milliamps. That's rather specific, isn't it? Let's test that. Let's get the death adapter in. Plug with this in gingerly, keeping my fingers well clear of the port in case it goes bang. It didn't go bang, that's good. Doesn't mean the output isn't live at mains voltage. Let's plug in this. It says 5.16 volts, that's good. And then hold this very metal exposed device. I was asked by a few of you where I got this from. This is a classic eBay. I've actually got a few of them. This is a load tester. from eBay, and it's basically, this one has sort of coarse and fine, and this one just has a little trimmer pot that you can set a load in it. And it basically, it's a current regulator. It acts as a fixed load that you can adjust, and it's got a fan to cool when needed. Oops, excuse me, belching. So I quite like this one because it's dinky. So let's plug it in and crank it up and see what we can get here. So at the moment it's displaying 0, so let's crank that up. Are you getting that display? Let's lift it up, that's the best bet, making sure I don't touch anything grounded. So far so good. 200 milliamps. Oh, that's not bad. It's 500 milliamps, it's still holding the 5 volts. 700 milliamps, let's turn it up. Oh, the voltage is dropping off now. Oh, right, okay. So it's still holding 5 volts, dropping a bit below it. It's managing about an amp. Oh, and the voltage just suddenly dropped. Right. Yeah, not quite an amp, is it? That before the voltage really tanks. So let's say 500 milliamp. Let's try the next one. Okay, the voltage in that one, the display has gone very, very dark indeed. It's displaying 3 volts. Let's wind it down. Down. Down more. Oh, here it comes, here it comes. So this one, let's turn it up slowly. It's not displaying. At 20 milliamps, it drops to 3 volts. So this is apparently a 20 milliamp output one, which isn't very good, is it? Okay, let's investigate further. So spudger, I'm guessing the ends will just pop out of these as they usually do. Usually in people's hands or when they pull them out of the socket. That came out very easily. That's one of these ones that will just get left in the socket. It's very classic. Let's see if they've done the usual thing that they do. That they have, well, there's an opto-isolator, and usually everything they've tried to get proper separation until it gets the opto-isolator, and then it just completely defeats it. Have they done that? Have they done that? Yes, they have. Ah, they always do that. Let's short out that capacitor, just in case it's holding a bit of a charge. Right, okay, that's it, discharged. So what have we got? We've got a fuse. Can you see the fuse there? It's the zigzaggy bit. We've got a single diode. Then that's going to the capacitor. Okay, very simple supply. They've got the classic 2 transistor system. They've got the feedback, which is, in this case, it's also very classic. It's a Zener diode. A little resistor probably across the opto-isolator. It is across the opto-isolator. Oh, hold on, let's doodle that. It's so classic. Basically speaking, the opto-isolator has 2 pins at one side, 2 pins at the other. And it's usually got something like a transistor inside. Can't remember the exact polarity of that transistor, but inside, can't even remember the exact polarity of that, they've got an LED. And they're optically coupled, so that's a light sensitive transistor, and this is usually an infrared LED, quite a low forward voltage. So what they do is they put a resistor across that just for stability, and then the supposedly 5 volts, they've got a Zener in reverse, and then that side is connected to this 0 volts, and as soon as the voltage exceeds the combined voltage of this Zener and this LED, then they start conducting, and that makes the LED light up, and it tells the primary side to turn off. It basically shunts the control circuit and says don't put any more power across, and that's how it regulates it. Very, very simple, really simple, and actually surprisingly accurate. It's about the minimalist they could do it with, which is very in keeping with these. So what they've done here, they've got this sort of generously sort of anti-tracking area. You know what? I could take a picture of this, couldn't I? And then we could take a close-up. Oh God, no, I've just seen something really horrific. Oh, I'm going to take a picture of this. This is horrific. Slightly smaller images so I can actually fit them in this time. So usually in the other cheapos, it's where the opto-isolator is that they've actually had this sort of like the breakdown of separation. In this case, they've made an effort, they've drilled holes and stuff like that. I'm not quite sure. I think that might be actually for thermal cooling, possibly, given the size of this tiny little transformer. But the area where they've breached the separation is here, and it's about 0.5 millimetre. But it's kind of worse than that, because these two pads here are actually for this capacitor, and that's this little capacitor here. And it is the interference pressure capacitor. Instead of using a proper Y-rated capacitor, they've just used a standard 1 kV rated 1 nanofarad capacitor. Now, the reason this capacitor is so small compared to what's usually there, if you've seen the normal class Y capacitors, the point of class Y capacitor is it's the only thing that's between you and the mains. It's designed for interference suppression, and the ceramic capacitors just generally have a layer of ceramic with a metal electrode on either side, and then the sort of wire coming off. And then it's the whole lot's encapsulated in resin to seal the water out, because if water got in, it would just become very conductive, depending on whether the ceramic had been treated or not to prevent water penetration. In the case of the Class Y capacitors, they make it thicker ceramic to provide better separation. That means you end up with quite a large diameter capacitor, because you need the larger area of the metallization on either side to compensate for the fact they're further apart. With the smaller, cheaper capacitor, you can use a smaller area because the two layers are much closer together. Instead of being a thick layer of ceramic like that, it's just this tiny shim with the metallization on either side. And the risk is that if that breaks down anyway, it's got a much lower voltage rating, or if moisture gets in, it's going to mean there's a much greater risk of current leakage across that from side to side. It also means that under high voltage spikes or even static electricity, it's going to potentially punch little holes through that ceramic, and it's going to create a sort of current path. So they've used the wrong type of capacitor there. It's not really compliant with any sort of safety standard. I've just pushed that and it just popped up in a sort of disconcerting way, that little transistor. I think I may have just... Oh! Rightio, I wonder if that was the problem. That is a dry joint, or is it actually physically broken? It's physically broken, but that might have been me that just did that right now. Oh! No, not 100% sure. No, it was putting out 5 volts, so I think that was me just now. I'm not sure what the problem is with the circuitry. Everything seems physically intact. There's a slightly dubious joint here, but it's not. It's making connection, and it is the primary circuit. I think that's a primary circuit. Is that a primary circuit? No, it's not. It's a secondary circuit. The feedback circuit. So that could be an issue. Oh, I should solder that and just see what happens. Although having said that... yeah, I'm going to solder it anyway, and then we'll try it out again and see if it works. No, it's not going to work, because I've just burst that bit. I'll turn the solder iron back off again. This isn't going too well, is it? But either way, poor separation, just who knows what the transformer's like. The temptation is to hike the transformer off and take a look. I'm just going to unwind the transformer now. Usually it takes a while to get the transformer part and unwind it, so I'll just pause momentarily. Oh dear. Oh dearie, dearie, dearie me. How about I can't see any separation between primary and feedback? I don't think there's any tape in between these layers. I think they're just wound straight on top of each other. Shall we investigate? So there's what I think is the first winding. Let's see if I can snap that out. So I'm guessing that's probably the feedback winding. It usually is the one that's wound last. Let's see if I can just grab that and unwind it. So that is almost certainly the feedback winding. It's not that many turns. And it is just wound straight over. It's wound right on top, without any tape, without any spacing. It's wound straight on top of the secondary. So zero isolation in this transformer. Let's see if there's any separation from the secondary here to the primary. This is scary. It makes me wonder how many of those other transformers are the same. It also makes it so clear that if for your own safety, you should not... Now, they have tape between the secondary and the primary, but the windings are going straight over the where the connections are coming in from the side. So it's not really properly isolated. And the wire here, it's not multiple, it's not what they call that triple insulated or double insulated wire. Oh, it's just so squirmy. That was just right down onto the primary. So if you look at the circuit board, keep in mind that the feedback winding was wound straight back onto the... so let's see the feedback winding. This is the feedback winding here, I think. Is it? No, that's the primary. That was the feedback. Let me think here. This looks like it is the... Is that the positive? It is the positive coming down. So that's the primary, and that's the feedback. And yeah, it's electrically connected. Both the windings are electrically connected directly to the main side. I mean, there is no effectively separation of the primary. So that is scary. You know, at least in some of the other ones, they've put a little layer of tape between them, and in the good quality ones, they try and keep the secondary just wound within that tape so it doesn't come close to these connections, but that's not the case in this one. That is scary. But now, let's take a look at this one instead then. So this is the second of these power supplies. It's a quadruple whammy, a triple whammy this video. We've had the LED lamp, which was quite acceptable in a way, although it's going to get quite hot. We've got this, which is absolutely not acceptable. So let's take a look at this now. This one was putting out the full current. Ooh. Right, let's grab that and pull it out and see what we can find. Ooh. So the fairly common arrangement that they have the mains voltage circuitry on one side and the low voltage circuitry on the other. They've got the opto-isolator, which has virtually no clearance. Again, can you see that? They've completely defeated the clearance there. So the mains, the primary side is just running right next to the secondary side here. On the circuit board, the connections are just rammed right up close to each other again. It's 1/4 millimeter. The circuitry is using the same two transistor arrangement. Mains is coming in, going through, it's got a full bridge rectifier this time. The Class Y capacitor is once again going to be one of these, yeah, they've used a 2 nano, by the look of it, as the Class Y sort of interference suppression capacitor, but again it's really not rated for that voltage. It is one of these pokey little ceramic capacitors. And the transformer, do I unwind the transformer? Do we take a look at the transformer? It won't take long, I'll just do that right now. Okay, well this one's off to a better start. The sense winding does have an insulation layer, and it's wound in a sort of central concentrated area. So let's get that off and see if we can dig a bit deeper. Oop, that's just tangled round. Tell you what, let's get the other side of that winding off. And unwind it the correct direction, shall we? Oop, very, very small wire. And then we'll check if the secondary, the output winding, the one you're going to touch, the one that already has pretty poor separation of the circuit board, we'll check if they've actually made any effort at all to keep it away from these other windings. So far, so good, but time will tell. Let's get this next layer of insulation off. This is where it would be really good having a proper... I've had no joy with autofocus because when you're working this close to the camera, it tends to focus in and out all the time. So it tends to have to be locked off. There is no camera suited to all applications. They're all aimed at sort of outdoor photography type things. I found that locked off focus is the best, but of course locked off focus is then only really focusing on one thing. It's something I'm experimenting with. I will be switching to a different camera soon, and hopefully that will allow me to step between focus points. We'll see in due course. So there's the primary. The primary is making an effort in this one. At least it is stopping a fraction of a millimetre short of just winding right over the the primary contacts. So in a sense, this one is a better transformer. Not ideal. You've still just got that layer of tape between the two and the sort of enamel windings. It's, when you come from my era, when electronics basically had like a core and two separate bobbins, one for the primary and one for the secondary, stuff like this is just a bit creepy. I do prefer the more, shall we say, Western compliant standards where they've made an effort to keep separation between the windings, or they use thicker insulation at the very least. These little transformers are just a bit freaky at times. So winding that off, how much insulation of this purple cable here do we have? Let's see if I can remove that. It may be wound too tightly to remove. Sometimes it just doesn't come off. Sometimes it looks like it's coming off and then just shreds and then just makes a mess. This one looks as though it may be that sort of shred and make a mess type stuff. Because it has been pulled tight that you can actually see sort of, you can actually feel the copper windings through it. So that has been pulled very tight when they've wound over it. I can really feel those sort of rasping under the screwdriver. Not good insulation. I think I'd rather have seen a few turns of that at the very minimum, and double insulated secondary. But this is really what we expect of these power supplies, isn't it? We just, you know, they're made. Who makes these? Who even comes up with the idea? Because if they're made for the Chinese market, it's 220 volts. It's just as hazardous as, you know, our 240 volt supply. So why do they have such low separation? So they were interesting to look at. But both of them are just an absolute fail. This one because it didn't put much current out. No really obvious fault, but still not putting the current out, not really been tested at the factory. Well, none of them probably has. And that one was just outright scary, the transformer. The windings were just wound over the top of each other. This one, on the other hand, had made some effort, but has absolutely appalling separation and an inappropriate interference suppression capacitor. So both fails, but quite interesting to look at anyway.